Good day, everyone. We are from Group 1. We'd like to present about the PBL presentation. The topic is about does caffeine consumption affect the reaction time? Next, this is our teammate, which consists of four people, which is Pavitra, Kushala, me, myself, Mishalini, and also Lavanya. Next, we're going to look at the objective of the study. The objective of our study is to determine whether there's a significant difference in reaction time between individuals who consume caffeine and those who do not. And the procedure we have done is we made a Google form was distributed to via WhatsApp, and also the participant answered the demographic questions and indicated whether they had a caffeine consumed or before the test, and also the participants then completed on the online reaction test time. The reaction test time in millisecond was recorded in the Google form, and the participants were grouped into caffeine consumers and also non-caffeine consumers. All the collected data were transferred into Microsoft Excel for statistical analysis. Once it done, an independent sample t-test was consumed and was conducted to compare the mean reaction times of both groups. Next, these are the raw data for the for the consumers, for caffeine consumers, and the reaction time in millisecond, and continued by the table with the non-caffeine consumers and their reaction time in milliseconds too. Next, these are the demographic table we got in from the Google form, which was the good caffeine consumers and also the non-caffeine consumers. And the sample size N we got was for caffeine consumers was 17, and the mean reaction time for the caffeine consumers we get was 459.47, and also the standard deviation in millisecond we got was 208.01. Whereas for the non-caffeine consumers, the sample size N was 24, the mean reaction time was 624.08, and also the standard deviation in millisecond was 441.82.
Now I'm going to explain about the mean reaction time for both the caffeine and non-caffeine consumers. First, we were able to get the mean reaction time by adding all the reaction time values for each group and then dividing by the total number of participants. This gives us the average reaction time for caffeine and non-caffeine consumers. From the result, caffeine consumers have a lower mean reaction time compared to non-caffeine consumers. Moving on, let's take a look at this graph of mean reaction time versus group of consumers. This graph is plotted using the mean values that was calculated earlier. It helps us visually compare the average reaction times between caffeine consumers and non-caffeine consumers. From this graph, we can clearly see that there is quite a bit of a significant difference between the mean reaction time of caffeine and non-caffeine consumers. Next, this is the standard deviation values that we got for the caffeine and non-caffeine consumers. The standard deviation was calculated by measuring how far each reaction time value deviates from the mean. So, to get it, we first found the differences from the mean, squared them, and then calculated the square root of the variance. These standard deviation values helps us to understand how consistent or varied the reaction times are within each group.
So, for the hypothesis testing, the first step is we have to make a hypothesis, we have to make the null hypothesis and alternative hypothesis. So, the first one is null hypothesis, which says there is no significant difference in reaction time between the two groups. Meanwhile, the alternative hypothesis is the claim. It states that there is a significant difference in reaction time between these two groups. So the second step, we have to list down the sample size and also the standard deviation. And we have to determine is it unknown or known. So N1 is equals to 17 and N2 equals 24, which is both less than 30. And S1 and S2 are unknown. So we have to use the t distribution here. And then we are given the level of significance is 0.05. So to find the value of 0.05, we have in t distribution, we need to find the degree of freedom using the formula given. And then we will get the output V equals to 39. And then we have to input the V value into the formula, which is T, level of significance divided by 2, comma V.
and we will get T 0.025 over 39. Sorry, comma 39. And we have to find these values in the T distribution table, and we will get plus minus 2.976. The third test is we have to compute the test value using the formula also, which is mean 1 minus mean 2 divided with standard deviation 1 square plus over n1 plus with standard deviation 2 square over n2 and square root these answers that down here. Lah. And then after we input all the values into the formula, we will get the test value is negative 1.64.
Next, I will explain about the hypothesis testing result for this study. In step 4, we compare the calculated test statistic with the critical values. The test statistic obtained was t equals to negative 64 at 0.05 significant level. The critical values are negative 2.976 and 2.976. Since the value is negative 6.4 lies between negative 2.976 and 2.976, it does not fall in the rejection region. Therefore, we fail to reject the null hypothesis. In step 5, we state the conclusion based on the decision. There is insufficient evidence to reject the null hypothesis. This means there are no statistically significant difference in reaction time between caffeine consumer and non-caffeine consumer. To conclude the study aimed to determine whether the caffeine consumption has an effect on human reaction time. Based on the independent sample t-test conducted at 0.05 significant level, the calculated t-value was negative 6.4, which lies within the acceptance region. Therefore, the null hypothesis was not rejected. Although caffeine consumer had a lower mean reaction time compared to the non-consumer, the difference was not statistically significant. In conclusion, the study shows that caffeine consumption does not have a significant effect on reaction time. That's all from us. Thank you.